Awesome.
Well, welcome everybody. Thank you so much for coming. I did just post a link to these slides on the general channel on the Slack if you want to follow along there. I'll just reiterate a big thank you that Anthony had already said, but to the organizing team and all the tutorial leads that have put a ton of time into the material that we're going to share with you guys over the next week. In particular, also just thanking NASA, Terrestrial Hydrology, Jared Enton in particular for support. And this data all got collected by quite a big group of people. So over 100 participants from over 20 organizations all participated in the collection of the data that you will all be working with. Again, big thanks to eScience Institute, Anthony, Scott, Joe, Jane, and Ann. Micah, and the two Micahs, Brian and Subnaught, for the development of and maintenance of the SQL database, all the organizers, tutorial developers, as well as the NSIDC team, and Megan Mason for data wrangling and all the data publications. The leadership team for SNOWEX in 2020 and 2021 has been myself, and Carrie Voyevich, who's the snow lead at NASA Goddard, as well as Kelly Elder at the U.S. Forest Service Rocky Mountain Research Station in Fraser, Colorado, Chris Heimstra, who's also with the Forest Service, and Mike Duran from Ohio State University. So yeah, big thanks to everybody that's helped make this happen. So I'm just going to talk for about 10 minutes, just on a little overview of SNOWEX for those of you that haven't learned about SNOWEX much. I also posted some resources on the general channel. There are videos if you want sort of a high level, so just sort of news related stuff, as well as recordings of our monthly meetings. Hopefully after this week, you will all get engaged in SNOWEX and reach out to myself or Megan about the monthly meetings, and hopefully you can start attending some of those. We have talks from folks that are doing work with the SNOWEX data, and possibly some of the work that comes out of the projects would be a great venue for getting presented there. So SNOWEX is a multi-year coordinated airborne and ground-based experiment to evaluate different snow remote sensing technologies throughout the season and in various landscapes. And so really what we're after with SNOWEX is we're trying to help inform a future snow satellite mission. How can we get information about the seasonal snowpack from space? And so SNOWEX is a bunch of coordinated airborne and field-based campaigns to try to help us better assess what would be the best approach to monitoring the snowpack from space. For those of you that don't have a lot of experience with snow, the driving sort of reason there is that about 75% of our water in the Western US comes from seasonal snow. And globally, it's over a sixth of the world's population. So over 1 billion people rely on the seasonal snowpack for their water supply. But we don't have very good ways of keeping track of how much there is everywhere at all times of the season. And we'd like to be able to do that from space. There's some gaps that have been identified that are sort of give a little bit of context into where we've been doing SNOWEX experiments. So there's a bunch of different snow climates, so snow packs in different environmental conditions that are listed on this slide, as well as the impact of forests on the remote sensing, wet snow, and better understanding of snow surface energy balance. There is a link on this slide. I've also posted it in the general channel on the Slack to the SNOWEX science plan. So if you want to dive a little bit deeper into kind of what the goals of SNOWEX are, I'd encourage you to take a look at that science plan. It's a large document, as well as the experimental plan for SNOWEX 2020 and 2021. Just to back up just a little bit of explanation here. So and a little bit of intro for myself. I grew up here in Seattle, went to University of Washington as an undergrad in the physics department. So I'm definitely a Husky, but I've now moved on to Boise State University, where I'm a faculty member there in the geoscience department, and I direct a group called the Cryosphere Geophysics and Remote Sensing Group. I did come back here to Seattle to have a heart procedure for a arrhythmia that was a problem that I was having. So just as an explanation, I'm here I won't be participating in the evening sort of get-togethers, but I really want to encourage those of you that want to reach out and connect with me, please send me a message on Slack. Come find me during this week. I will be here all day, every day, but just not hanging out in the evenings, as I still have a lot of rehab I'm doing. Let's see. So, yeah, and in general, I'll be kind of rotating around through the different project teams, and you can ask me any questions about SnowX. I've been kind of living and breathing it for about the last 4 years. So I really want to make sure I'm just available as a resource for everybody working on their projects. Let's see. So go to the next slide here. So a little just overview of what SnowX in 2020 and 2021 actually was. This is the data sets that we'll be working with this week. So there were kind of 3 components of SnowX 20 and 21. So there was a time series experiment with a specific type of radar called INSAR, and there will be a tutorial led by Jack and Zach that will go into kind of more of the details on that. But we flew 14 different sites over 5 states, weekly to bi-weekly in both 2020 and 2021. And there were field teams in each of those 14 sites that we're going after in the overpasses. We were testing that sort of approach to retrieving a change in snow depth and a change in snow water equivalent from this specific type of instrument. And so we had groups on the ground and an aircraft in the air. So that was kind of one big piece of SnowX. The second big piece was a very detailed experiment, what we would call an IOP, or an intensive observation period, on Grand Mesa, Colorado. We kind of brought all these different approaches to one place. We had 5 different aircraft in the air that were carrying a total of 7 different airborne instruments, all instruments that we were interested in evaluating from a snow remote sensing perspective. And that took place in 2020, in February of 2020, as a 19-day snow on campaign. We also did a snow off campaign prior to that in November. A lot of these approaches are change detection. We make a measurement from a remote sensing platform when there's very little snow, and then we make a measurement later when there's more snow, and we're looking at how did that signal change between those 2 periods? Can we use that change to tell us something about how much snow is on the ground? The final piece of SnowX experiment over the last few years is an albedo experiment that took place in both Grand Mesa and Senator Beck. These are 2 sites in Colorado, and the goals there were to evaluate spatial variability and controls on albedo, and how does terrain and vegetation impact those retrievals. Albedo is the fraction of energy that is getting reflected from the snow surface. And it's one of the key metrics to be able to model snowmelt. That approach also developed data sets helpful for evaluating a specific satellite upcoming mission called the Surface Biology and Geology, or SBG mission. As you get more into sort of this NASA-related work, there's a lot of acronyms. So definitely reach out if there's an acronym you don't understand. NASA loves to use acronyms, and it's almost like a different language. So please post questions about that kind of stuff on the Slack. An acronyms channel would be awesome. If someone wants to make an acronyms channel, that would be sweet. Because a lot of them are a little bit confusing too. Like this is a good example on this slide, the summary of SnowX in terms of the first bullet point on the last slide, the time series, is an instrument called UAV-SAR. It's actually not a UAV. The original proposal was for a UAV, and they kept the name. So it's a little bit confusing, but UAV-SAR is the instrument platform that we flew. It's an L-band, which specifies the frequency in SAR system. There were lots of different folks from lots of different universities that participated in this, and I have them listed on this slide. And again, we were testing an approach for snow depth and snow water equivalent change using this INSAR technique. One of the reasons we're interested in this is there already is a satellite that's getting launched in early 2024 that will give us this data every 12 days at 50-meter resolution everywhere on the planet. So there is this potential, if we can get this working well and test it from this airborne platform, that we'll be able to start applying it in the upcoming years. I'll let the UAV-SAR tutorial folks go into more detail, but the basic idea is just We make a measurement from the satellite to the ground when there's no snow, or when there's a certain amount of snow. We do it again after some snow has fallen. That slows the signal down, going all the way down to that ground surface, and we use that change in the time of flight to estimate the snow on the ground. Just this second slide here is just some recent results showing, that it is related to the change in snow depth on the ground as measured from a LiDAR instrument. To just orient you in terms of kind of where we did these measurements, there's a slide in the deck, INSAR time series sites. So in 2020, before the pandemic shut us down, we were flying 13 sites distributed across the Western US. And then in 2021, we chose a subset of those sites where we were trying to fill in gaps from the previous year. So as a summary, there were 10 overflights in 2020 or in 2021 and 6 in 2020. We did a lot of LiDAR observations, but only in a subset. The LiDAR is much more expensive and we can do it a lot less frequently for the same budget. So we have a subset of sites where there is LiDAR available. And in the context of SNOWX, because we don't see a path for doing that kind of LiDAR measurement of snow depth from space, those LiDAR data sets are really part of our calibration and validation approach. So Megan's going to go into a bunch of detail and some hands-on examples with the core data sets that was actually measured on the ground. We also have a tutorial on the LiDAR data. Those two combined are kind of our primary evaluation data for the other techniques. So be looking for those tutorials as your sort of your metric for how well a technique may work. See, I'm going a little bit fast, but happy to go through these slides as well with folks if there's other questions. So on Grand Mesa, lots of ground observations. We had people running around digging snow pits in the snow that Megan will talk more about, doing depth transects, scanning with a ground-based laser scanner, as well as measurements with both passive microwave and active microwave instruments on the ground, and then other tools for characterizing the fine details of the microstructure in the snowpack because they influence the remote sensing. And then there's just a list there of I won't go through them all in detail, but of the 7 different instruments that flew during this effort. We're going to be focusing this week on a few of those in particular, largely because last year, the feedback we got about Hack Week was too many tutorials. We kind of saturated everybody because there's so many data sets. So we honed in on sort of aspects that are the closest to helping us solve this problem from space, and the ones that are being pushed forward in either satellite mission concepts that are already planned to be launched, like the Albedo one that I mentioned before, or the NISAR one that I mentioned before, as well as a few remote sensing techniques that are in the process of proposal development for a future mission concept. So you'll be hearing about some tutorials about the Albedo problem from Chelsea and Joe, from Shaolin and Rashmi on the signals of opportunity, sort of more of a passive, sort of bistatic radar approach, from Dylan and Batu on the SWISAR instrument, which is another active and passive microwave instrument. These are the ones that we're trying to evaluate. How can we use these approaches to measure snow from space? I talked about the UAVSAR one already. We're going to have some tutorials on data access. So that'll be both from NSIDC as well as from Micah and Micah, who will be talking about this SNOWX database that contains all of this data. And then to kind of help us wrap around, bring all these data sets together, there'll be a couple important tutorials, one on snow modeling and one on machine learning that help us kind of tie these different data sets together, or potentially be, important pieces for helping us interpret all these various different data sets. Okay, and I'll let you guys take a look at all the things that we did on the ground, and Megan will be talking a little more about that as well. In terms of the Albedo, again, I talked a little bit about the sort of main objectives, but I'll let the AVERSENT G tutorial kind of cover that in more detail, but there's just some slides from Mackenzie Skiles that go into a little bit more detail of kind of that approach. Again, trying to better understand how much energy from the sun is getting reflected versus absorbed into the snowpack to help us predict melt. Okay, so I'm going to wrap up just with the final couple slides here. So really, snow science is a team sport. When we go out and do one of these big campaigns, we never do it just by ourselves. We have to have, for safety reasons, more people with us, but there are so many measurements that we need to make during these aircraft experiments. They end up including lots of people from lots of different organizations and universities. But what's happened in the past is then people would go off and do their own science with it, maybe just within their university group, maybe just by themselves. And that analysis part, there hasn't really been a structure for a collaborative effort in that way. And so I think Hack Week really is this opportunity to make the analysis part a team effort as well and provide equal and fair access to all of the data, as well as building up a code base that everybody can use to help us push these efforts forward. So I want to encourage you to provide credit where it is due. If you take this work and move on, try to acknowledge the tutorial leads and the data observers that helped, that you're basically standing on shoulders of what other people have done. We're all going to be doing that this week. So just keep that in mind. If you're going to end up using this in your thesis work, try to acknowledge the people that you used, material that they share where you can. Try to ignore this fear of getting scooped. I think that's one of the big things that has been a barrier to sharing code and data is people are worried about somebody publishing before they have an opportunity to. I think the snow community is in a very different place now than it used to be 20 or 30 years ago, where there wasn't a whole lot of data. We are very data rich. We have so much data right now, we don't have enough people to look at all of it. So I think that idea that you're going to get scooped if you share what you're doing, we're going to try to ignore that because you'll benefit a lot more from sharing your work and sharing the resources that in terms of data that you have. And that's really what I think will lead to new opportunities and a rapid increase in knowledge. So I want to thank everybody here for dedicating a whole week of your time. A week is a long period of time to focus on one thing. So I appreciate you taking the time to come here and help us to build this open science culture for SnowX. And you're now part of the SnowX team. So I hope that you stay connected with this community. Wanted to just bring this up for those of you that haven't seen this paper. It's been referenced quite a bit in Nature, just about sort of the progress that we've made in increasing diversity over the last 40 years in geoscience in particular. Cryosphere is a subset of that. But basically what this graph is showing is that we haven't really changed the diversity equation in the geosciences in the last 40 years, especially if you account for changes in population. And so this is something that is important to the SnowX group, and we really want to welcome and strongly encourage participation from people of all backgrounds, races, religions, and gender. And in some ways, open science is a bit of an equalizer. It creates this environment where you have equity in access to data and software that promotes inclusion. If you have any ideas about how to improve this, Cryosphere is even worse than geosciences in terms of diversity. Please reach out to me. It's something that we really want to make progress in particular with the SnowX platform. So I'll just wrap up that with a thanks. I am available for anybody if you have questions, you want to talk about SnowX, various data sets or approaches. I'm going to try to circulate and be a resource for all of you. I'm not a very good Python programmer. I've done MATLAB for over 20 years and I still haven't broken out of that. So I will direct you to other people if you have Python questions, probably, unless it's something fairly simple. But I'm trying to make that switch, so I'm here to learn as well as all of you. So excited for this week, and I'll turn it over to Megan.
Was it telling you to go to the internet?
Hopefully I don't turn anything off or let this drop. Hi everyone, welcome to the first in-person SNOACS Hack Week. Going off of last year's excitement online that was had. Yeah, it's good to see everyone here. This is really exciting.